A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. We shall be starting in a couple of moments. Yes, Simran, it is the first session. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep IAS. Welcome to the session of Geography, where from today we shall be initiating a journey for the subject of geography, and over the next 24 modules, we shall be covering this entirety of the subject. And in fact, everything which is relevant for your portion of civil services examination, both from the prelims, mains perspective, and also the type of questions which are generally asked from this area, even if you end up reaching to the level of interview and even when you appear for the personality test. So, everything within the purview of the examination, which is important for the examination, is something that we shall be covering here. Now, here, when we initiate the subject of geography, first of all, the basic query that you must be having, or you should be having rather, is that when you decide to become a civil servant, when you decide to appear for this examination, why is this subject required for you? Why is it that UPSC requires you to get an idea and a detailed understanding of the subject? So, this is a subject which is important for your examination at various different stages, and there's a reason for that. And that is basically because when you take a look at the world around you, when you take a look at the region around you, you will find geography at play in your day to day lives. For example, recently you had the occurrence of one of the very massive tropical cyclones and storms which occurred across the eastern coastline of our country, which led to substantial amount of flooding in the region around Chennai and the eastern coast. Now, why that tropical cyclone is created and when is it that it does hit the coastline? Now, in order to understand that, you need an idea about this subject. Now, being a civil servant, let's suppose when you get selected for this examination, you are supposed to basically cater to the region, you are supposed to take care of the requirements and development of a region. Now, in your region, in whichever area that you are living in, the agricultural productivity is always going to be dependent upon the type of soil, the fertility of the soil, the amount of rainfall. In certain years, you end up expecting very high amount of rainfall and you receive a lesser amount. And sometimes the vice versa cases also happen. India, as a country, whenever it experiences a failure in occurrence of rains, thereby almost immediately you have the widespread impact, which is felt even in the case of economy, and the overall the political setup of the country also gets impacted by that. Now, geography ends up determining not only how the history in a region has panned out, but even the present social structure in terms of the food habits, in terms of the customary costumes that you basically witness, the cultural traditions that you observe, and also the historical political setup in a particular area. Everything is determined by geography for that matter. And this is an example that you might have heard before as well. If you take a look at Our own history, we went through a substantial phase of colonization, a substantial period of colonization where the Britishers and the Europeans, they came over to India and they colonized us. Now you would have read about advent of Europeans in the portion of history. But if you think about it, why is it that the Europeans came over to these countries and these areas? Everything is determined and is driven by geographical realities. So geography ends up driving the history of a region, ends up driving the life of a region, and also ends up driving the geopolitical and the geostrategic importance that a region has. It is for this reason why UPSC expects you to be proficient in this subject. Now, this is a subject which is considered to be in the UPSC lingo, so to say, amongst the big four. In UPSC circles also, you have four major subjects that is very, very essential, which carries a substantial amount of weightage for your examination, including the areas of polity, history, economy, and geography. All of them, they get a substantial amount of weightage in your examination. So, even if, let's suppose, we are not able to encompass or comprehend the larger picture, that where is this subject going to help us and why are we supposed to read all these areas, just think about it, that its importance for the examination is so significant that you have to go through it. So, in this first module that we are going to cover, the introduction module, we are going to address some of the very basic things, such as when you initiate any particular subject, you have a certain set of queries. What is it that we are supposed to read? What is it that the syllabus is going to be about? How is it that we are going to approach the subject? What is it and how is it that we should carry out the revision of it? And what is going to be the classification and the division of the subject? So, starting first of all with the aspect of the importance of geography. Now, as I told you, the importance is lent in the area of prelims, in the area of mains, and also in the area of your interview. In interview also, whether you are appearing for the interview of civil services or forest services, even in forest services, you do find questions, for example, about the forest distribution across the country, the distribution of different types of forests that you have. You also come across interviews in civil services where you have questions being asked about decreasing agricultural productivity in India, the issues in agriculture. Why is it that the farm income is continuously decreasing? Those are the areas where basically you find the questions to be asked from. But when we talk about the overall weightage here, in the portion of prelims here, first of all, you have questions directly around 15 to 16 questions every year are asked from this subject. Now, here I'm not going to sugarcoat it, and that is something that I want to set the trend for the remainder of the 24 sessions also. Those of you who would have attended the sessions previously, you would attest to the fact that we would keep it as blunt, as honest as possible. So I'm not going to sugarcoat it that all the questions will be in the prelims will be asked from the PPT itself. For the mains, I can give you that kind of a guarantee. But prelims, the nature of the examination is such, you will have certain factual questions, 2 to 3 factual questions out there. But if you are thorough with the portion of current affairs, the portion in news, and the portions which have been taught in the class along with the discussions that we have, let me assure you that out of the 15 to 16 questions asked in the examination, 10 to 11 questions should be easily solvable by you. Then it depends upon how fluent you are with the portion of current affairs. You can take this number high up to around 13 to 14 out of it. So think about it. Out of 15 to 16 questions being asked from one particular area, if you have the potential to get around 13 of them correct, that is substantial. 26 marks you can attain directly from this particular subject. And then you have other basic subjects also, polity, economy, the modern history, etc. There also, if you end up getting a similar strike rate, you will be easily through the prelims examination. So that is where this particular and these set of modules are going to help you quite substantially. In the mains examination, amongst the portion that we are going to confront and amongst the portion that we are going to study, in the mains examination, you will get questions in GS paper 1, where directly questions from geography are asked. And in GS paper 3, you get questions from the portion of agriculture. So here in geography, you generally encounter questions worth 105 marks. And in GS paper 3, you encounter the portion of agriculture, where you can get or expect a question of around 45 to 50 marks. So thereby you can think about it that there is a substantial amount of portion that you can cover with this particular area. Now, out of these particular areas, again, for the portion of geography, I can assure you, and even for that portion of agriculture also. But in the portion of geography, if you take a look at the past trends of the question, past 4 to 5 years of questions which have been asked in the GS paper, almost 90 to 95 marker questions, they come directly from the portions discussed in the classroom. So think about it. 90 to 95 marks. That kind of a strike rate you barely find in other subjects, right? Other than maybe polity governance. So that kind of a strike rate is very high. So out of those 90, 95 marks, if you follow the basic fundamentals of answer writing, you will be able to secure somewhere around 65 marks to 70 marks easily. And then think about it. In paper 1, what is the weightage of paper 1? 250 marks. So out of 250 marks, inclusive of society, inclusive of history, art, and culture, if you are able to secure 60, 65 marks or 70 marks in the portion of geography itself, you can easily aim for around 110 plus in GS paper 1, which is quite rare. So that will give you a kind of a competitive advantage, which will be simply unparalleled. Okay. So here, that is where it is going to be very, very relevant. Then, not only in this subject directly, but even if you consider the allied areas, the associated areas, such as, let's suppose, the portion of environment ecology, environment and ecology, if you consider even the portions of disaster management, now even in these portions, if you have the understanding of geography, you will be able to complete and comprehend these areas very easily. For example, if let's suppose when we talk about environment, what is it that we talk about? We talk about the biosphere, the living species across the planet. Now, the kind of species, the kind of plants, the animals that you find in a particular area, that is always a sum product of the climate of a region. So if we talk about the region of, let's suppose Siberia or Canada, where you have extremely cold conditions, you will only have certain type of species living there. When we talk about certain species which live in, suppose, India, that will always be a byproduct and the sum product of the conditions that you expect and experience in India. So that is why your understanding of geography is very pertinent for you in order to get an overall view of even environment and ecology. And there, your idea and your awareness of geography will help you. For example, in areas such as coral reef systems, right? Your understanding of geography is directly going to help you there. Your idea about the global climate, world climate that we are going to study, that will help you understand the different types of biomes which exist in the environment and the adaptations that the species in the deserts, the species in, let's suppose, the tropical rainforest, what kind of adaptations do they go through? Okay. Now, what is it that you study in disaster management? disaster management. Here, basically, you come across events such as how do you manage the disasters such as earthquakes, floods, cyclones. Now, if you know why do they occur, what are the features associated when you have these disasters occurring, then obviously managing and management of those disasters comes as a natural successor of it, isn't it? So that is where even your portion of disaster management should never be read in isolation. Please do not commit the mistake of reading these subjects in isolation. These are your natural follow up from the portion of your geography and your knowledge of geography itself. So that is where this subject is going to lend you significant amount of help. Having said that, when we talk about this particular subject, we are basically going to study this subject spread over 24 different modules. And those modules, we will be classifying it based upon what amount of concentration is required, stress is required in different areas. Based upon that, we shall be classifying that particular module distribution also. So when we talk about the classification of the subject in itself has got a different type of classification. Many of you associate it with world geography, Indian geography, human geography, economic geography, right? Many of you do that. But if you take a look at the notification that is issued by UPSC tells you that you should have an idea about the geography of India and the world when it comes to physical, economic, etc. Now, here, the broader classification that we are going to pursue is going to be of two parts. That is physical geography. It is with the help of this physical geography where we are going to basically take that opportunity to cover the portions of the world also. Okay. And when you talk about, let's suppose, the portion of Indian geography, this is where we are going to cover the portion of economic and human geography also. Okay. Now, here in the portion of physical geography, we are going to cover it in the portion of the landforms, first of all, that is the portion of geomorphology, where we are going to discuss about, let's suppose, the existence and the presence of various landforms spread across the world. Why is it that the region of Pacific Ocean is surrounded by deep oceanic trenches from all sides? Why is it that the fringes of the continents, they have the presence of fold mountains? We are going to discuss about what kind of landforms exist across the world when we talk about, let's suppose, the erosional, depositional landforms, glacial landforms, riverine landforms. So with the help of this physical geography, we are going to cover the portions of the world. Now, then comes one of the most conceptual portions in geography, and that is going to be the portion of climatology, where we are going to spend most of our energy. Because climatology not only is conceptual, significantly conceptual, climatology helps you understand lifestyle around you, the kind of plants, agriculture, etc. around you. It helps you understand the food habits which are present in different parts of the world. It helps you understand what are the different economic activities which are pursued in different parts of the world. For example, if we talk about the region, let's suppose, again, if I take the example of Siberia. Now, Siberia is one of those frigid areas or frozen areas where basically everything gets frozen for most of the parts of the year. Now, agriculture cannot be carried out because the soil in itself gets frozen. So, agriculture is not going to be one of the strong suits here, isn't it? So, that is the case of climatology. Here, we are going to study phenomena that you would have heard about, many of the things that you won't find to be present in the books, such as, for example, we will be studying about Walker circulation, Enso cycles, then jet streams, Indian Ocean dipole, Madden-Julian oscillation, the concept of, let's suppose, Indian monsoon, western disturbances. So that is something that we are going to discuss in detail as per what the latest analysis and the latest findings they tell us. That is where we shall basically be taking that liberty of exploring the portions slightly beyond what is immediately given in the books as well. But that will only be done in order to deepen your level of understanding. Okay, then we are going to come across the portion of oceanography, where we are going to discuss the oceans of the world, the types of ocean currents across the world, what are the features of salt content in the oceans across the world, what are the different types of circulations experienced across the world. That is something that we are going to, and you are going to witness and study here. So the world geography is going to be covered with the help of these three larger modules and larger units of physical geography. When it comes to the portion of Indian geography, here we are going to go for the detailed analysis of physiography of India, physiography of India, we are going to study about the detailed analysis of, let's suppose, the portions of soil and forest, which many of you associate with the portion of biogeography, then drainage systems and rivers of India, drainage systems and rivers of India. Then we are going to cover the portion of what you consider under the area of economic geography also. That is, we are going to cover areas of agriculture, minerals and industries, Indian monsoon is something that we are going to cover, and also population and settlement. Now, this is what you consider under the portion of human geography. Okay. Why I am describing it is because I oftentimes find the candidates, they start panicking after the 20th or the 21st module, but we have not covered the portion of biogeography. You have covered it. You have covered it in different heading. But we have not covered the portion of economic geography. You have covered it under different topic. We have not covered the portion of human geography. You have covered it under different topic. We have not seen about the world geography. You have seen it under different context. So overall, the analysis of it is something that you will always be able to understand if you analyze the previous year questions. Now, if I tell you about the module distribution also here, so module 1 to 5 will be spent in the portion of geomorphology. Then module 6 to 12 you will cover under the portion of climatology. Then after that, oceanography module 13 to 16, or rather 15 itself. That is the portion of oceanography. Then module 16 to 23 will be the portion of Indian geography. And then comes module 24, which will be of mapping. Which will be of mapping. So that is going to be the detailed coverage. And as a student, you should know. As a candidate, you should be aware about the long-term plan also. It is not only your right, but also will help you plan your study accordingly. That, okay, this amount of foresightedness, if you have that, okay, this much amount of time we will be spending in this particular area, in this particular unit. That will provide you with some kind of peace of mind also, which is very much required while you carry out your preparation. At the time of your preparation, anxiety and anxious moments is some of the last things that you basically need. Now, coming to the material list. What are the materials required? So, when we talk about the materials required for this subject, again, I would reiterate, as I have reiterated multiple times, keep the material list to the minimum. Okay? Please do not have bulk amount of materials. Regardless of whatever the market around you, regardless of whatever the various your peers, your competitors, your seniors, whatever they flood you with the idea, let me tell you with a certain degree of certainty and assurance, keeping the material list to the minimum is always going to benefit you. Okay, so always follow that mantra in your life. It is always better to read the same book 10 times as compared to reading 10 books, which you can read only once. And trust me in this when I say that UPSC doesn't require you to study many different books. If that would have been the case, then only those of them who would have who would have completed the masters in subjects of geography, economy, political science, etc., only they would have qualified for the examination, isn't it? But why is it so that people who come from varied and different backgrounds, they end up clearing the examination right in the first attempt? Whereas you will find people who keep on studying various different books, they have become book collectors, but they will never become district collectors in their life. Please strive for becoming the district collector rather than a book collector. So please don't start going through various different types of books. Now, for the basic understanding, many of you have initiated the preparation of geography right now. Many of you have been attending or have basically attended the class for the first time. So, for the beginners, let me tell you that the class PPTs plus the additional reading materials that we provide, additional reading materials, now these two would be sufficient. Okay, this is the material which you should be very thorough with. Very, very thorough. You have to be very, very thorough with this. Okay. NCRTs. NCRTs available online easily, free of cost. NCRTs can serve as your process of revision. Many of you have got the pre-recorded lectures also. So those of you who have those pre-recorded lectures, rather than the NCRTs, you can study that also. So that will be just your mode of revision. Now for NCRTs, it is again very simple. Class 11th and 12th. Okay. Class 11th and 12th NCRT, you have 4 to 5 NCRTs associated with the subject of geography for class 11th and 12th. More than sufficient. Now, other than this, in case you are finding it difficult, only then go for class 6 to 10th NCRT. But 11th and 12th NCRT should be sufficient because this is written keeping in mind the students who are in class 11th and 12th. And obviously, it is not at all complicated. It is written in very simple language. So class 11th and 12th NCRT, that coverage should be enough for your revision. Then Atlas. Any atlas of any publication for your GS, that would be sufficient. But what to look forward in the atlas? So the concepts of geography that we study, let's suppose we have studied about the presence of mountains in different parts of the world. Immediately look at the atlas, look at the regions that have been talked about. Don't think about it that one fine day when everything will be working for you, when your preparation will be completed, then you will open up the atlas and that will be very productive for you. No, don't have that approach. Atlas is something which should be covered, which should be gone through on a regular basis, as regular basis as possible. Any atlas, any publication, right? And I'm not going to validate this, that I have this atlas, will that be okay? I have that atlas, will that, any atlas that you have, more than sufficient. But your study of atlas has to be associated with the portion of concepts and regions covered in the class, in sessions, and current affairs. For example, in 2022, UPSC asked a question in prelims that which of these countries border the region of Afghanistan? Now, multiple options were given. Now, immediately the candidates, many of the candidates rather, they were able to solve it, but few of the candidates, they were stuck in a kind of a panic mode that what is this happening to UPSC? Does UPSC expect us to remember all the borders, all the countries? No. UPSC has asked you the question about the bordering area of Afghanistan simply because Afghanistan has been in news. Simply because in the year prior to that, there had been a substantial amount of withdrawal of troops from the region of Afghanistan. So unrest would be created in the bordering areas around that. That is why UPSC asked you that question. This year, UPSC asked a question about the bordering regions of Ukraine. Again, because that has been in news. The Russia-Ukraine war, the region around South China Sea, the region around Mediterranean. So you will find that even in the portion of mapping, UPSC doesn't go random. It doesn't throw random questions at you. The people there, they are not going to ask you about your general knowledge. They are going to ask you about your general awareness. This is what differentiates this examination from the lower grade examination that you have appeared for, or that you basically see your friends appearing for. In the lower grade examination, basically you will have the questions pinpointing you about some random place in some random continents because they stress on your general knowledge. Here UPSC seeks to ask and seeks to inquire, what is your overall understanding? What is your overall idea about a particular region? So that should be the process or the approach for the coverage of atlas. Again, I will reiterate, any atlas that you have, right? And any kind of atlas that you have will suffice. Any edition that you have, Oxford Atlas, Student Atlas, TTK Atlas, any atlas that you have would suffice for this. Okay. Now, newspaper is a must. This is a must, not only for the portion of geography, but here understand newspaper is not only for your portion of current affairs. Many of us, we do commit that mistake where we think that newspaper reading is only for the portion of current affairs. It is never the case. Newspaper reading is not for the portion of current affairs only. While current affairs will be augmented, but then that current affairs you can basically assimilate even in the portion of monthly magazines, etc., or the news analysis that you hear through. That also gives you the portion of current affairs. So why newspaper reading? Newspapers help you develop your own perspective, that what is happening around you, what is happening around the world. And that perspective development is very important. If let's suppose you want to weave an answer which gets multiple different areas interconnected together, the best answers in the mains examination is not where, let's suppose, a question has been asked about water scarcity, and if you are only talking about the geographical pointers there or the environmental pointers there, that is not the best. That is the average answer. Any person appearing for the mains examination will have the proficiency and that intelligence to do so. So what will differentiate your answer? your ability to interrelate it to the political scenario, to the economic scenario, the economic impact of it, your ability to interrelate it to, let's suppose, the lowering agricultural productivity in a region, your ability to interrelate it to the water scarcity in a region. So the more you are able to interrelate the various concepts, better is your understanding, better is your answer. You will be better even in your essay writing, and also while you face the interview panel. So that is something which is a must. Other than that, newspapers, they also help you develop the art of answer writing. It is famously said, Stephen King had said that the more you read, the better you are able to write. So the more you are able to read, right? And newspapers, they basically give you very long explained articles, editorials, where you will see that the authors or the writers there, they have got the very unique ability to move the perspective of discussion from one area to another area in such a swift and smooth manner. That is what is required even when you write the answer. Your answer should not be abrupt. Your essay should never be abrupt. It should always have that flow, always should have that consistency. Where do you learn that? By reading your general NCRTs, or let's suppose books like Lakshmikant. Do you get that ability? Absolutely not. You learn that ability when you go through these. So that is why newspaper reading is an absolute must. Okay? Now, here, this is basically required. This is the material list. Keep it to the minimum and use the NCRTs if you want, even for your revision purposes. But in the sessions, please do ensure that the PPTs plus the ARMs are easily and always covered. Now, when we talk about the module progression, we have already talked about it, that basically geomorphology, climatology, oceanography, we will study. All of them will help us understand the portion of Indian geography. Now, in the portion of modules also, or in the materials also, keep on updating yourself with the current trends, if possible, with the portion of the magazines. Which magazine? Down to Earth. Down to Earth is a magazine which will enrich your understanding of, let's suppose, the agrarian crisis, the conditions of, let's suppose, any new technology which has come up with, which talks about rainwater harvesting. Whenever you talk about deforestation and its impact on the rainfall pattern. So, Down to Earth is a magazine that you can go through, and that is where it will enrich your idea. Okay, so this is one of the magazines for the portion of current affairs. Now, many of you have the kind of a conception, or have a kind of, let's suppose, doubt about certain books, such as, if newspapers can't reach your area, go for the online edition of it, the PDF edition of it. GC Leong and Majid Hussain. Many of you would be recommended with this GC Leong and Majid Hussain from your surrounding also. Many of you would have bought it also. In case you have bought it, fair enough, you don't have a choice but to study it. But in case, let's suppose, you are only being pressured by your friends, your peers that study GC Leong, study Majid Hussain, don't get swayed by it. GC Leong is not important for your, or has not been written for civil services aspirants. GC Leong is not a book which has been written keeping in mind civil services aspirants. Keep that in mind. Okay, so this is not associated, or this is not linked with the civil services aspirants. Okay, so you can have some amount of leeway in that, because if you analyze the previous 10 years question, you will not find a question which has been asked in the examination which is not mentioned in the NCRTs, or which has not been discussed in the class but is present in GC Leong. No. So why to elongate your book list? Then Majid Hussain, many of them will suggest to you that for Indian geography study Majid Hussain, let me tell you, the portion of the PPT plus your portion of current affairs will more than suffice. So even this is not required. required. Keep the material list to the minimum. Now, what is the approach that is required? Approach to study. So, first things first, if you are attending the sessions, one thing that I ask out of you is being regular. That is a must. Why I tell you? Not because I want you to see my face on a daily basis and I gain a particular joy out of that. That is not the case. But this is a subject where, when we initiate the discussion, and those of you who have attended the sessions, if at all previously, you would attest to that again, that basically each and every topic we shall be initiating the discussion from the very base, from the very basic portion, right? Right from the very basics, we will assume that no one knows anything about it, okay? And from that, we will be picking it up. But after that, we shall be building concepts one upon another. And we shall be building concepts of very difficult areas also, right? For example, when we talk about the concept of, let's suppose, a tropical cyclone, it is very much dependent, or Indian monsoon, it is very much dependent on the rate at which the land area gets heated up and the rate at which the oceanic regions get heated up. And that will be covered in the basic portions. So if you have missed, let's suppose, a particular class, a particular session, you will find it a bit difficult for the coming concepts. Okay, it is not, and this is where the subject is slightly different from the areas such as your history, areas such as polity. Well, let's suppose, even if you miss out a couple of areas in the portion of modern history, let's suppose you have missed out a couple of classes when 1857 revolt is being taught about, or when Canal revolt is being taught about. Let's suppose you have missed a couple of classes. Even after a couple of classes, when you come back, you study about the Swadeshi movement, you study about partition of Bengal, Surat split. It makes sense. Something that you will be able to follow. Let's suppose you have missed that also. You join the class and 1921, let's suppose, non-cooperation movement is being talked about. You will be able to associate with that. You will be able to relate to that. But here, if you have missed the portion of plate tectonics, then your understanding of why volcanoes erupt in a certain area will be very limited, will be very restricted. You will be turned to mere spectators in that case. If you have missed out one or two classes, let's suppose, of the basic portion of the case of Indian physiography, then why is it that the region of Chota Nagpur Plateau, Karnataka Plateau, or Bastar Plateau is rich in minerals? That is something which will simply bounce over your head. If you have missed a couple of sessions in the portion of climatology, then, and suddenly you join in the portion of tropical cyclones, nothing will make sense, right? This is where majority of the candidates, they commit mistake. Majority of the candidates that you come across, they would have heard somewhere in the news headlines that, okay, an earthquake has occurred. I need to know about the earthquakes. But do you know the basic why the earthquake occurs? For that, you need to understand and have a clear-cut conception about the plate tectonics. Otherwise, someone might tell you that earthquake happens because of shaking of the landmass. But why is it that earthquake occurs only in certain areas? Why not in the region of Peninsular Plateau? Why only the region of Himalayas? Why only the region of southern part of Europe? Why only the region around Pacific Ocean? So if you want to have a deeper understanding of the subject, just be regular in the sessions. And let me assure you, if you are regular in the sessions, if, let's suppose, for the next 24 modules, you forget everything else, you just be regular. And by regular, I don't mean that stare at the screen and expect some magic to emerge out of screen. By regular, I mean be attentive. If possible, make a running notes out of it. Any important portions that you find, that something which you don't find written in the PPT, but you find in the class discussions that something important has come up, make a note of it. Use that for your revision. Revision should be carried out on a daily basis and a weekly basis. If, let's suppose, daily basis is not possible, at least minimum on a weekly basis. For example, today, tomorrow, day after tomorrow, whatever we are going to cover, you should be able to revise it on the weekends. That is when the following classes will be much more productive. Your purpose here is to extract as much as being taught as possible, right? The best out of it. And trust me, from these portions that have been taught, candidates have been able to score very well. Even this year, we have many candidates who have basically qualified the mains examination. And many of them, personally, I'm hopeful that at least 2 to 3 of them will get a double digit rank, because depending upon their level of preparation. So if you want to not only perform a duty that, okay, I have this class which is listed in the batch, let's get rid of this class, and then after that, my preparation, that is never going to happen. You have to extract maximum out of it. And here, we are going to follow an approach which is not going to be bounded by chapters. So please don't hold the expectation that tell me the page number to page number for this module so that after the class I can revise. You are not in class 8th anymore. Or for that matter, if you have done this class till class 10th, you are not in class 10th anymore, right? You are preparing for your civil services examination. You are going to compete with the best of the best. And for that, you have to put your best foot forward. In many of the areas, we basically are going to discuss certain portions which are not there in the books, any of the reference books. For example, Madden-Julian oscillation, not present in many reference books that you go across. Madden-Julian oscillation, maybe in the latest edition, 1 or 2 references might be there, but nobody is going to talk about why that is getting created or what that is in detail. So we are going to go through and exceed the foundations of the book, and that is why you are attending the live sessions. If let's suppose this was supposed to be one of those sessions where, okay, open page number 1, in page number 1 this is being this is written, that means this, now turn the page, in this second page this is written, third page this is written. If that would have been the purpose and the modus operandi, basically a simple audiobook translation of NCERT would also have solved the purpose. But I'm sure you're not here for that. You are here just for 2 reasons. First, you need to gain an edge over your competition, because be very clear of one thing: 4.5 lakh to 5 lakh candidates will appear for this examination at the prelim stage. Out of that 5 lakh candidates, out of that, around 10,000 will only succeed. Only 10,000 will appear for the mains examination. Only 10,000, right? So if you have 10,000 people appearing for the mains examination, all of them would have studied the same books, if not more than you. So what gives you that edge? Why should the examiner give you more marks as compared to the rest of the people who have also studied the same books, if not more than your what books you have covered? So you need a competitive edge. For that, these live sessions will be helpful. We will be able to assimilate topics of different areas. And when we discuss the previous year questions, I will also be able to authenticate that many of these portions that we are discussing directly is being asked in the examination. So that edge. And secondly, in order to clear this exam, you are not here to be geographers in your life. I'm sure none of us are present here and attending these sessions that I want to be geographers and I want to become a geographer or a climatologist. No. You are here. Your agenda, your purpose is simple. You want to clear this examination in the first attempt, in the first go, whenever that attempt is. And for that, the approach is going to be different. We are not going to be reliant on many of the written portions. Many of you have the idea or the habit, rather. Again, this is something that we have inculcated. Many of us have inculcated from our school days itself, where we would simply sit in the sessions, we would open up a notebook, and whatever would be written on the board, we would simply copy that, and that would be our notes. No, that is not the approach we are going to follow. Here, geography is something we are going to study from the visualistic perspective, where let's suppose we are going to actually try to visualize what goes on around us, what is the planet around us, and that is something which needs to be internalized. Okay, so the basic thing is that you have to be regular. For interview, you generally have around out of 10,000, you have 2,100 people who get selected for the interview. Out of 2,100, 2,200, depending upon the vacancy, you have around 700 which get selected through the final merit list. That is the overall ratio. You have to be regular. You have to open up your mind to newer ideas that this can also happen. You have to be observant about the region around you. For example, if a question is asked that what are the problems of urban settlements in our country, or what are the problems faced by urban areas in the country, no book can do justice to your information for that. Whichever region you are living in, you would have seen the problems around you. You would have seen the problems of the growth of slums, poor hygiene conditions, occurrence of diseases, urban flooding, pollution. You would have witnessed that. Just express that. So be observant and as much visualistic as possible. I'm not going to cater and pander to the fact that give me the written portion of it in the PPT itself, so that I will simply be a collector of the annotations of the PPT. Leave alone when I will become the district collector. First of all, let me be the collector of the resources. You don't know how busy my life is. I have to attend my college also. I have to go to my friend's birthday party also. I have to go for that social event also. And still I'm attending your class. That much amount of goodwill I'm showing to you. What else do you expect out of me? Elevate yourself. Okay? Elevate yourself from these menial things. You are appearing for this examination, prestigious examination, which is being conducted, which has been conducted in this country for more than 100 years now. Various different examinations are conducted. Hundreds of examinations are conducted across the country, many of whose value goes up and down. UPSC has got that merit associated. And it is because it selects the best of the best candidates. And you don't become the best candidate by simply sitting and staring and having that collection of the annotations. Be proactive. Write it down. Wherever you find something new, wherever you've come across a new set of information, write it down. Okay? Before every PPT, before every topic, from my side, I will tell you what kind of questions can be asked in the prelims examination from this, whether this is relevant for your mains examination or prelims portion. I will be making you familiar with that, but the remaining portion of it, you have to work on your own. It is your journey. You are the one who is going to decide whether you succeed or you fail. And spoon feeding is something I don't believe in. Regardless of how you judge it, spoon feeding is something we don't believe in. So, we are going to cover this subject to the deepest of the depths, more than what you can imagine. We are going to go into that depth with the help of the various examples. We are going to explore those depths, but the rest is up to you. Okay? Now, after this, we initiate the discussion for the subject, right? Any doubts that you have before we initiate the subject and the discussion of the subject? Any kind of doubt? Okay. Mail ID will be provided to you. Any tip for note making? Just keep an A4 sheet paper or a notebook in front of you. Whichever portion you find to be new or something which is not there in the PPT but is discussed, make a short note, a bullet point about it. Swati, the class PPT and the notes that you are preparing, plus the current affairs. Which newspaper is best? Either the Hindu or the Indian Express. Okay. Additional reading materials will be sent to you on a day-to-day basis. It is rather available on the app itself. You can access the additional reading materials through the app. Lakshmi, you give homework for us daily? No. I expect you to revise what is being covered in the class on a daily basis. I expect that maturity. I will not give you that homework because, again, I want you to elevate your level. In newspaper, which part we will read? Any news article which you find will be relevant today, is relevant today, will be relevant 5 months down the line, will be relevant 1 year down the line. That is the portion that you have to go through. Additional reading materials, Lekhani will provide you with the written definitions of many of the areas, the many portions that you see. Okay. Map practice, Sonu, can always be done if, let's suppose, you have the case of the maps or the atlas, any portion that we cover. Let's suppose we cover about the international dateline today. Open up the atlas. Look at the international dateline. Look at the regions around it. If, let's suppose, we cover the formation of mountains or plate tectonics, we cover that oceanic trenches are there. Open up the atlas. Where are the oceanic trenches? Open up the atlas. Where are Andes? Where are Rockies? That would be more than sufficient. Okay. And please tell about overall revision of topic you will teach each day today. Okay. You want me to tell you the topic today itself, that what we will be covering on a daily basis right up till January? So again, that is not going to happen, because some areas will require a greater deliberation depending upon whether you are following the class or not. And always understand that the level of discussion that we are going to have in the session is always going to be dependent on you guys. If you guys are revising enough, if you guys are receptive enough, I will always elevate the level of discussion to a point where it will be simply quite advantageous as the point of view of competition. But let's suppose you come without any kind of a revision, where even the basic portions of evaporation condensation becomes very hard to comprehend, then we will keep it very simple and slow. So that is where having that kind of a topic wise distribution in the first class itself doesn't make sense. Okay. And Nayana, I'm facing difficulty in understanding the geography subject. Please tell me the approach. Follow the class. Be regular in the class. Be regular in the class. After each session, revise what has been done in the class. Just do that for the next 10 to 12 modules. You will automatically find your comfort zone. NCRT Palukonda can be used as a point of revision, if at all. Hemnand, we will be talking about the answer writing also. Yes, Prasan, that can also serve as an alternative. Can you please provide daily 4 to 5 questions based on the previous sessions? No. PYQs would suffice for that. Daily, if you have 4 to 5 questions, what is the requirement of that? Will you write answers on a daily basis, 5 answers on a daily basis? So in that case, many of the areas you won't even be able to understand. Many of the areas are not that important for the mains examination. Not that approach is not required. For example, after every module, after every rather unit of geomorphology, let's suppose we discuss 7, 8 questions, previous year questions. Then you have the weekly tests. On Saturdays, you will have 5 subjective questions which will be uploaded. The PYQs plus those questions that you take, more than sufficient. In that itself, let's suppose you have 4 to 5 of these weekly tests. You have a pool of around 20-25 questions plus 20-25 PYQs. You have a good pool of around 40-50 questions. Practice answer writing in that, more than sufficient. Okay. There is a belief that Indian Express does not cover much from. No, it is not that. Either the Indian Express or the Hindu. Okay. How many times revision is needed before appearing for the examination? At least 4 to 5 times. Any standard book that we must read for the knowledge of geography? No. The basic things. The basic portions of the class, the NCRT is more than sufficient. Okay. Ashwin, each year mountain pass, national parks and sanctuary are asked. Is it so, Ashwin? No. Every year it is not asked. Every year you'll find one question out of it being asked. In one random year, maybe 2 or 3 questions are asked. But if you analyze that, it is always based on the portions which are in news and the portions of current affairs. Okay. Amritansh, that will be with practice. You will get an idea about drawing diagrams. Shelja, revision from PPT would also be sufficient. Do we need to read NCRTs parallel to your classes? No. Just revise the PPTs and go through the written text of the additional reading material, sufficient. Abhijit, if you can revise with that book also, that is also sufficient. Okay. Lakshmi, I'll do that. How many years of newspaper is most important? So newspaper reading should be done from today itself if you are not in the habit. Newspaper reading should not be done that. See, assimilation of current affairs and revision of current affairs can be done 12 months or 18 months before the exam. But newspaper reading, the idea of the various perspectives around it, that should be done from the day when you start the readings, maybe from today itself. Even if you are appearing for 2025, 2026, whenever you are appearing for it, start the reading today itself. Okay? Right? Yes, Vaibhav, you can do that. Is it necessary to show areas in map for specific questions? Yes. In the answer writing for geography, drawings are, and drawing of maybe flowcharts, the rough images, they are a must. What if I have Majid Hussain and GC Leong both? Should I have to read them? No, not needed. But after the end of the session, after all these 24 modules have been completed, if you want to revise through them, fair enough, go through that. Okay. But let me assure you, the class and the discussion in the class, more than sufficient. But sir, reading newspaper is tough if we don't know what type of things to read and avoid. Any suggestions? Again, I'll tell you, avoid the political news. One political party has said anything about the other political party, avoid it. Not at all going to be asked. Think about it. Whenever you come across a news article, think about it. What kind of question can UPSC frame from it? Will UPSC frame a question that which particular state has got this chief minister? No. Will UPSC ever ask you a question that this political party said, what about the other political party? No. So only those questions basically which are going to be consistent, only those particular areas in newspaper, for example, international relations, which talk about a long-term thing. Not if today Joe Biden says something about Xi Jinping, tomorrow Xi Jinping says something about Joe Biden. Not at all important, right? So that is where newspaper reading has to be selective. Ideally, 1.5 hours to 1 hour 45 minutes is sufficient. Okay. When do you do PYQs? After every major unit is over, we will discuss the PYQs. And here, let me also tell you one thing. Understand. Please don't get that preconceived notion that your questions are being avoided, that your questions are not being answered to. We have the very well qualified subject matter expert also who have basically cleared the mains and appeared for the interviews multiple times. So they are going to try their best to answer your question as promptly as possible. It might happen that while answering your question, it might have a certain lag. But please don't be that candidate where at 6:05 you have sent a question. At 6:06 you send a question mark. At 6:07 you send a double question mark with a kind of a angry emoji. At 6:08 you send three question marks with multiple emojis. At 6:09 you say that this is the worst experience ever in my life. My questions are not being answered. Why is my question? I am also. Don't have that approach. Be a bit mature. There is no reason why your question won't be answered. Have patience. We will answer all your queries. Okay. It is never going to be a preferential approach. I don't know any of you personally. Let me tell you that also. Right. Few of you might have attended my club batches previously. So I might be aware of those names and I might be aware of those habits. But please don't get that mentality. That victimhood mentality is the worst mentality that you can develop in your life. I hope you are aware of that when you're preparing for civil services. That bad things are happening with me. I am being basically tortured. Don't have that mentality. It is our prerogative to answer your question. Your question will be addressed. In case, let's suppose, your question is not addressed. Let's suppose, what is the worst? Your question is not addressed for 20 minutes, for 25 minutes, let's suppose. Is it the end of the world? Is it the case that now the entire batch is futile for you? The entire subject becomes futile for you because your question was not addressed there? No. Move on. Try to understand the next things which are going up for discussion. And whenever at the end of the session, put up that question. Let's suppose your question is even not answered there. Let's suppose we are not able to cater to your question even then. Send us a mail. I will give you that written reply. At the end of the class, I will answer your questions. Okay? So please don't develop that victimhood mentality. Okay? Basaya, you can go through for that for revision. Right? I hope all those who have been writing this, you understand that. Okay? So now, let us start the discussion. I hope I have covered all the bases. So now, we initiate the discussion for the subject of geography. Now, when we talk about geography, here, this is a subject or this is an area which is very, very old. Herodotus, basically, around 450 BC itself, he studied the region around Nile, River Nile. River Nile, I hope we are aware, it flows through the region of Africa. And basically, Egypt and the entire Egyptian civilization, it settled around River Nile. Herodotus, at that point of time itself, made a conclusion that Egypt is the gift of Nile. That is where even today you come across that kind of an adage, that kind of a saying, that Egypt is a gift of Nile. Basically, River Nile made the region fertile, and that allowed productivity of crops, and that is where people settled in. Now that river, when it would meet the region of Mediterranean, it would form a fertile delta. That is what was studied. Then Aristotle studied that further. Like that, geographers have existed for thousands of years. In fact, whenever Alexander basically moved through his conquests, he would always carry a cartographer. Cartographers are basically the ones who are good at drawing maps. And Alexander would always carry a cartographer so that the map of the world could be understood because he had the aim to conquer the world. That is where it is said that when he basically was returning from the banks of River Indus, at that point of time, he sent a cartographer and a certain set of people across this River Nile to explore the other route back to Greece. So, people have always been curious about the world around them. Always. And as humans, when we gain that intelligence, that question still persists amongst us. That is, what is our place in the world? What is our role in the world? What is the role that we play in the world? That question has always been ever so persistent. Now, in that scenario, in that particular backdrop, when we talk about the subject of geography, it has had various different phases where explorations were carried out. For example, ancient Greeks were aware of the fact that if through the Mediterranean somehow you end up moving to the Atlantic and sail to the north, you come across areas which are completely frozen. They were aware of the fact that if you come towards the region of equator, you will find the heat level to be so very high that it is intolerable. They called it the torrid zone or the intolerable zone, where nobody could survive, nobody could live. That is the name that they gave it to the region around equator. But at that point of time, earliest of the humans, they would always be staring up at the sky and wondered about what their role was, what their place was in that wide world. And that is something we are aware about it by looking at the cave paintings. Many of the cave paintings, they depict these paintings of the sky, the stars, the alignment of the stars, which tells you people were always curious about their place of the world. Initially, you had the major belief that Earth was the center of the universe because people would see sun rising up the horizon and setting down the horizon on every day. They would see that sunrise and they would see that sunset happening on a daily basis. So everybody thought, and they could basically see the stars also slightly having that motion. So initially, the belief was that planet Earth is the center of the universe, and the entire universe simply ends up moving around Earth. They would see the sun moving through, they would see the moon moving through. So the belief came in that we are at the center of the universe. That earliest idea of geography, which was obviously quite false, quite wrong, that was what was known as the geocentric model. Geo refers to Earth, centric means the center of universe. Geocentric model of universe, which basically talked about Earth as the center of the universe. Now, over a period of time, obviously, this was significantly contradicted. People were aware, became aware that Earth is nowhere the center of the universe. Then came the belief that sun, because sun was treated as a god, right? Even today, in many customs, even today in our culture, we treat sun as the god, isn't it? Now, it was thought that sun is the center of universe and we move around it and the entire universe moves around it. At that point of time, our understanding of the universe was quite restricted to the solar system that you come across. So that model where sun is considered to be the center of the universe, that was considered to be the heliocentric model of universe. Now this prevailed till quite late. Even when you talk about the various models of universe, for example, provided by Kant, Laplace in the 1700s, even then you will find that their understanding of the universe was only restricted to the solar system itself. They had no idea about the other galaxies, etc. But with the advent of newer techniques, technologies, era of exploration, which is referred to the 1700s and 1800s, where basically when a lot of various discoveries were happening, 1900s and the early decades of 1900s was the era which is considered to be the pinnacle, in the sense that many of these individual discoveries could now be assimilated to understand the broader functioning. That is when various models for stars, origin of universe, they started coming into place. Now here, Einstein's role is also very important. Einstein, through his theory of relativity, he talked about the fact that energy does not get destroyed or created, it simply changes its forms from one form to other. Light can get converted into heat and so on. Right? Energy can get converted into mass also. E equal to mc squared, the very famous formula of Einstein. So that basically became prevalent for a very long time. Then you had, obviously, in the early years of 1900s, you had the development of telescope. Now, one of the American astronomers with the name of Edwin Hubble basically, he observed something unique. While he was observing the world around him, the stars, etc., around him, he basically observed, and as he was matching it up with the previous data, he observed that each of these stars and each of these celestial bodies and objects, they are moving away from each other. It is not as if they are moving towards something else. All of them are moving away from each other. So that basically brought a kind of a postulation. And that was that the entire universe around us, it is expanding. It is basically moving away from each other. So Edwin Hubble is always associated with the theory of expanding universe. Theory of expanding universe. Everything is moving away. Einstein's formula, I won't go into the scientific details of it. Basically, Einstein's formula had also predicted it that there is a gravitational anomaly, there's a significant amount of gravitation exerted by all of these objects, etc. Now, this theory of expanding universe was postulated by Edwin Hubble. Meanwhile, you had scientists such as Lemaitre and Gamow. Lemaitre and Gamow, they were working on the concept, and Gamow, they were working on a simple concept. And the concept was that if, let's suppose, the objects are here right now, if the stars are like this, if, let's suppose, the solar system or or the various different other solar systems, they are at this present state, that means, as per the theory of expanding universe, they are moving away. That means 10,000 years back, they would have been slightly closer to each other. That means millions of years ago, they would have been further closer to each other. That means billions of years ago, they would have been further very close to each other. That means around 13.8 billion years back, they would have been a singular mass. And they refer to this singular mass as singularity. And they basically postulated the fact that this singular mass underwent an explosion, because this singular mass would have existed at that point of time, around 13.8 billion years ago. And this singular mass would have had very high temperature and very high amount of pressure, which they would have experienced. And they would simply have exploded. As they would have exploded, basically, things would have started moving away. Just like in the case of, let's suppose, a balloon. Think about it. During the birthday parties, you have balloon which is filled with all the various paper pieces, confetti, etc. When you burst that balloon, everything spreads apart. Right? If you move back time, everything was contained in one place, but because of that explosion, everything moved apart. So Lemaitre and Gamow said that, look, there was a singularity at 13.8 billion years back, and there was an explosion. That explosion meant everything started moving away, and it is still moving away. So, the genesis of the entire universe that we see around them is, or the birth of the everything that we see in the universe around us, that is dependent on that explosion which happened. And they named it as the Big Bang. And that is when the Big Bang theory came into existence, which talks about the fact that around 13.8 billion years ago, everything was simply exploded. It started moving away. And slowly and steadily, as you would move away, and as, let's suppose, the explosion would have happened 13.8 billion years ago. So let's suppose after 1 billion years, things would have started to cool down. Then vapor would have gotten converted into liquid, liquid to gas, atoms would have come into existence, atoms would have led to formation of molecules, various different molecular combination would have led to formation of solid particles. Solid particles basically initially itself, let's suppose hydrogen atom consists of one electron. Hydrogen atoms would have gotten together, nuclear fusion would have occurred, heat would have been produced, that would have attracted more hydrogen, more heat would have been produced, and stars would have been born. So everything around us is dependent on that big explosion or the Big Bang. So the Big Bang theory provided by Lemaitre and Gamow, it basically talked about the existence and the formation and the origin of the entire universe. Now this is the image of universe, observable obviously, observable universe, captured by the telescopes. Hubble telescope was the most powerful telescope that the world had, till we launched the James Webb telescope. James Webb telescope is now the most powerful telescope that mankind has. Now basically, observe these various different shapes and sizes. These are not stars, these are galaxies. Each of these galaxies of various shapes and sizes, they consist of billions and trillions of stars. Billions and trillions of stars. Think about it. The sun is a star. So, our sun has got a solar system. And the heat of the sun, the mass of the sun, keeps all the planets around it. So, think about it. How many planets across the world or across the entire universe must be in existence? Galaxy, again I will reiterate, is formed by millions and billions and trillions of stars. We live in the Milky Way galaxy. Our sun and the solar system is a part of the Milky Way galaxy. And there also, we are not at the center of the Milky Way galaxy. So basically, if let's suppose this is considered to be the Milky Way galaxy and its stretch, here, our position is somewhere here. So even in our own galaxy, we have millions and billions of stars. Many of them we don't even know about. There are many such millions and billions of galaxies. Many of them we don't even know about. So the universe around us, we know very little about universe around us. And that means basically we have observed only a part of the existing universe. There is still a lot more to explore in the world around us. Okay, this is where many of the scientists, they gave the theory that, okay, basically, if you have so many planets, so many stars, so many planets, so many worlds around us, life must be existent. But that is a different debate and discussion altogether. But that is about the origin of universe. And it all started with the Big Bang. And that is where the world is still, or the universe is still in the expanding form. So here, when we talk about it, the Big Bang theory was born of the observation that other galaxies are moving away from our own at great speed in all directions, as if they had all been propelled by an ancient explosive force. Around 13.7 to 13.8 billion years ago, everything in the entire universe was condensed in an infinitesimally small singularity, a point of infinite denseness and heat. Everything was condensed in a small mass. Suddenly, an explosive expansion began, ballooning our universe outwards faster than the speed of light. And this is where, observe, this is the artistic or a kind of a scientific depiction of the Big Bang. Think about it. This is the event which is referred to be happened, which has happened around 13.8 to 13.7 billion years ago. Now, when that Big Bang happened, at that point of time, the temperature is expected to be close on 10 to the power 32 degrees Celsius. 10 to the power 32 degrees Celsius. Right? Imagine how many zeros you would attach to that. That much amount of temperature. Then immediately after Big Bang, it started cooling. So within milliseconds, much shorter than millisecond. So let's suppose after 1 second, the calculations they tell us that after 1 second of the Big Bang, the temperature would have reduced to 10 to the power 10 degrees Celsius. Everything would be plasma, gas. Okay. Then slowly 3 minutes after Big Bang, further cooling would have happened. Materials were traveling faster than the speed of light. This is when, if materials they travel faster than the speed of light, Einstein had said that energy can get converted into mass. E is equal to mc square. Right? If you have energy and if things are moving at a speed faster than the speed of light, it can get converted into mass. And that is when he said that basically you had the atoms which started getting formed. And eventually, many, many millions of years ago, you basically had the formation of atoms, molecules, matter came into existence. And we, humans, we are very latest additions. Just to give you a timeline, just to so that you have a clear-cut idea, Big Bang happened, and we have evidences of Big Bang, which happened 13.8 billion years back. Solar system and planet Earth got created around 4.5 billion years ago. 4.5 billion years ago. Life is said to be evolved, or life came into existence on the planet around 3 billion years back. So even after formation of planet Earth, for almost 1.5 billion years, you had no life. And after 1.5 billion years, that is 3 billion years back, planet Earth had got those microbes, single-celled organisms, which started coming in the oceans. We humans, we have come here only few 100,000 years back. So think about the time scale of it. Before us coming onto the planet, you had many different events across the planet. Many different species have come and have gone extinct. Many various different species have gone extinct. Around 99% of the species that planet has ever witnessed, they have been extinct much before even we humans got here. So we are very latest additions to this planet. So when we try to study the planet Earth, we try to study a history of 4.5 billion years. That is why this history is different from the time scales that you study in the portion of ancient, medieval, modern history, where when we say long time back in your portion of history or your syllabus of history, we say Indus Valley civilization happened a long time back. We are only talking about 5,000 years ago. But in geography, when you say that the youngest fold mountains are the coastal Cascade Ranges in North America, they were formed around 2 million years ago. Himalayas, whose height is still increasing every day, Himalayas, they are referred to as young mountains, one of the youngest mountains on the planet. Himalayas came into existence 65 million years ago. We humans, we came into existence only a few thousand years ago. So that is why the time scale here is going to be a bit different. Okay? Now, then humans basically came as a result of evolution. There you have a whole evolutionary process behind it, the kind of a consistent and a constant tussle between the reptilian and the mammalian mammal species, basically, that eventually led to the rise of apes eventually. And those apes, they evolved. It is said that the first form of humans, or the Neanderthals, that we are the descendants of the Neanderthals, they came into existence in the region around Tanzania, roughly around 500,000 years back, or few estimates even put it to around 100,000 years back. And from there, they populated the entire world. They moved across from Africa they moved to Asia. From Asia, through the region of the Bering or the region of Alaska, they moved into North America and they populated the entirety of the world. So that would basically be how the universe came into existence. So it is very important to have that larger perspective in mind. Now, here, the Big Bang Theory, basically it says that universe as we know, it started with an infinitely hot and dense single point that inflated and stretched, first at unimaginable speed and then at a more measurable rate over the next 13.7 billion years to the still expanding cosmos that we know of today. So, just a moment. So, that is basically now our planet Earth and the solar system that came into existence around 4.5 billion years ago. I'll tell you about the formation of Earth in detail, that how the Earth came into existence, how the Earth evolved into the present case, from a molten ball of mass, how the planet came into existence, how water came into existence. We will be talking about that also. But basically, the solar system was created around 4.5 billion years ago by the formation of the sun. And sun is the largest, it is the star of the solar system. The sun in itself came into existence around 4.5 billion years ago. Now, I hope we are aware of the basic sense of Newton's theory of gravity. Newton's theory of gravity basically tells us anything which has mass will always attract other objects also. It will be dependent on the mass of the other object, the distance between them. But any object which has got mass will attract the other object. So Newton had famously made that claim, which in a way angered many of the conservationists at that point of time. He basically said that, look, my finger can attract the stars also. Basically, he said that, look, my finger has got mass, the stars have a mass. So there is a gravitational pull which can exist. It is different the matter that my finger is almost uh, has got very, very little amount of weight and the distance is so very large that the gravitational pull will be inconsequential. But anything which has got mass will have the force of gravity. And that is the basic reason why all the planets they move around the sun. All the planets they revolve around the sun, they move around the sun. That is because the sun is the bulkiest object in the solar system, so it has got that highest amount of force of gravitational pull, so it will basically be pulling everything. Even the moon has got mass. Moon also pulls. It is the gravitational pull of moon that results in the formation of tides. It is the gravitational pull of Jupiter which influences the planet's orbit. Every 1 lakh years, after every 1 lakh year, Earth's orbit goes through a slight change. So gravity is the key point here. Now, when we talk about the solar system here, sun, even though in this image it appears to be different, but sun is the largest object and sun has got that bulky mass. And that is where the sun is able to pull everything. Right. Now, that is why everything moves around. And if you have to understand this, basically, think about it. Let's suppose when we talk about why is it that it moves all around the sun? Why doesn't it simply fall into the sun? So, for that, understand the simple basic concept. Here, if I have this pen, I drop this pen here. It will drop simply like this, isn't it? Why does it fall? Because of the force of gravity, it falls. But let's suppose this pen has got some velocity. if I throw it with a velocity, will it fall here? No, it will fall somewhere else. So if this pen, let's suppose here, if I drop it without any velocity, if it is static, it will simply fall. But let's suppose this object is traveling with a speed. Now it will fall somewhere here, right? That is the logic that you follow when you throw a ball. If you have to throw a ball for a large distance, you put more force behind it so that it falls after a greater distance. So you try it here also. If you consider, let's suppose the sun. If you consider the sun, and then you consider, let's suppose planet Earth. Now, planet Earth will ideally be pulled by the sun. It will try to fall towards the sun, but it has got some velocity, right? Since the time of forming, it has got some velocity. So, planet Earth, rather than falling straight away, it will come somewhere here. Here again, it will be attracted by the gravitational force, but it has got some amount of speed. So planet Earth, rather than straight away falling here, it will basically come somewhere here. Again, force of gravity to sun will try to pull it towards the sun, but it has got some force. So it will basically move here. It will come here. Again. So that is how the planets end up moving around the sun. Right? So that is basically how the planets they move around the sun. That is the same logic which is used while launching satellites. Why do you think when we launch satellites, what are the satellites? Satellites are the small objects that will keep on moving around the planet Earth consistently. Now, why do you think you attach those big rockets, that heavy fuel load of rockets, in order to launch the satellite? Because you want to give those satellites that velocity, so that with that velocity, even if it tries to fall on the planet, it will have that motion. It will have that revolution around the Earth. So greater the velocity, greater will be the circulation. That is why heavier the satellite, more heavier is the rocket which is used. So this is the reason why the planets they rotate around the sun. They move around the sun. Planet Earth moves in a kind of a anti-clockwise direction. How did planet Earth get that force? How is it that the velocity came into existence? Right since the time of its formation. It basically, when we talk about it tomorrow, that how the planet Earth, if we get time today itself, we will talk about it, that how planet Earth got that formation of it, how it happened. It happened as a result of multiple collisions. So every time a collision would happen, it would have that force, it would have some speed. And multiple of these trillions and trillions of these collisions, eventually, when they would form a planet, the planet would have some speed. And that is why it would move. Okay, so that is the case of the planet Earth moving around the sun. But as the planet Earth is moving around the sun, it is also rotating. So is the case with all the planets. They also rotate. They rotate around its axis. Just like a ball, if you rotate a ball, it basically rotates around one of the central points. So this also rotates. Now here, we do know that when the planet Earth rotates, one portion of it is exposed to the sun, the other portion is hidden from the sun. The portion which is hidden from the sun experiences night, and the portion which is exposed to the sun, that experiences daytime, right? So this portion, for example, will experience day, this portion will experience night. This is what we refer to as the circle of illumination. Circle of illumination. That differentiates day and night. The planet continues to rotate from a direction of west to east. Right? So if the sun is here, let's suppose, the sun is here. So it rotates from west to east. So that is why, let's suppose, as it moves, we say that the sun rises this particular portion. Let's suppose you consider North America. This is the continent of North America. So the eastern part of North America will experience sunrise first. That is why it is always said that sun rises in the east, sets in the west. Okay? Now, when we talk about the rotation of the planet around its axis. Now, Earth, it is not a perfect sphere. The shape of the Earth is what is also referred to as a geoid. That is, it is slightly bulged at the region of equator and it is flattened at the region of the poles. This is what is known as a geoid. It is bulged around the region of equator, flatter towards the region of the poles. Okay, so there is a slight difference in distance here. This distance that you consider, if you consider this d, and if you consider this, let's suppose, to the region of equator as d1, right? So you will come across the fact that d1 is slightly greater than d. Okay, because it is flatter around the poles. Now this planet is consistently rotating around its axis. Always, this planet is consistently rotating around its axis. So let us understand another concept here. Or do we take a break now? Okay. We'll take a break and then we'll come back and we'll understand the concept here. Okay. West to east. We'll talk about the speed of rotation of different parts of the planet when we come back after the break. So let's take a break. We'll take a break. Initial sessions. Let's take a break of 15 minutes. Let's be back after 15 minutes and we'll talk about the latitude, longitude, speed of rotation, etc. Okay, let's be back after the break. Why sun not move and stay on one position? Sun moves. The velocity of sun is very, very high. It is just that we are moving along with it. If I have to tell you a kind of a rough depiction of it, basically, if I can show you the rough depiction of it, let's suppose this is the sun. This is consistently moving at a very high speed around the Milky Way. Just that the planets, they are rotating much faster around the sun, somewhat like this. So that is a kind of a complex three-dimensional motion. So in order to simplify it, we say that the sun does not move, but the sun also moves with a very, very high speed. It moves around the region of the Milky Way galaxy. Okay? Okay. Let's take a break and let's be back. A confirmation about the audio, please. If the audio is clear, thank you. Vandana, as you told that sun is much more bigger and having much energy than planet Earth. If sun is attracting sun towards itself. No, as I told you, Vandana, please understand that sun tries to attract the planet Earth towards itself. It is that force of gravitation due to which there is that consistent falling which happens. And but because Earth has got a velocity, it doesn't directly fall into the sun, but it has got that kind of a motion where it tries to fall, but it comes here. Again, it is getting attracted rather than falling directly, it comes here. Rather than falling directly, it has got the velocity, so it reaches there. So it is that simple concept. Okay, right? And why we can see only one side of the moon, Tanishta? That is what is referred to as tidal locking. It again is due to the gravitational attraction of the Earth, and the gravitational pull of attraction by the Earth is so strong that it consistently has one side of it facing it. Just a moment. Okay. Now, an announcement about the feedback forms. The feedback forms would have been sent to you, and whichever subjects you would have attended previously, please do fill the feedback sheets and send it back to us. Okay. Nayana, as I told you, sun is not always attracted. It is not that sun is static. Sun is also in motion, and the planets keep on moving with respect to the sun. So if you think about it, sun has got a motion like this. It moves around the Milky Way, and then the Earth simply, along with the other planets, they keep on moving around the position of the sun. Okay. Why planes are not attracted? Planes are also attracted. That is the reason why planes basically have the speed. When you move in a plane, do you think that the plane is static in the air? It moves at a speed of around 800 kilometers per hour. So 700, 800 kilometers per hour. So it is because of that speed, because of the lift, the aerodynamic lift, that is why it stays up. Cosmos basically refers to the universe around us. Is there any chances of to collide between the Earth and the other planets? No. Each of them have their own orbit, which has been formed as a result. But previously, collisions have happened. In fact, when we take a look at the formation of a moon, that was because a Mars-sized object actually went and collided with the planet Earth. So that is how moon came into existence. Okay. Now, that is the case of planet Earth and its motion. And it is not the case that circle of illumination came into existence. At any point of time across the planet, if let's suppose the sun is here, the planet is rotating, only half of the planet will get that light. Remaining half of the planet will be away from the sun. So, whichever imaginary line that you can think about, which distinguishes the lighted portion and the darker portion of the planet, that can be considered to be the circle of illumination. Can we assume that other galaxy also had a sun and other planets? You can assume that the other galaxies have millions and billions of sun, and each of them will have their own set of planets. Okay. Why the orbit changes from elliptical to circular? Because of the gravitational pull of the Jupiter. Okay. Now, why most of the planets are circular? Because when you talk about the planets, they consistently rotate. Anything which rotates, for example, take the case of a when you make chapatis or when you have a dough. So if you roll that dough continuously in a rotating motion, it forms a circle, isn't it? So the planets, as they are rotating due to the force of gravitation, they will have that. Sun also does rotate. That means planets have three type of motion. Which three types of motion? You are talking about that circular motion, the rotational motion, yes. As the asteroid come out of their belt, as any of this planet come towards us, yes, asteroids have gone through multiple collisions with planet Earth. That is how the life on planet Earth basically almost came to an end 65 million years back, when you had the asteroid which collided with planet Earth. And that is virtually what put an end to the era of dinosaurs. Otherwise, if asteroid would not have collided at that point of time, dinosaurs for all standard purposes would have existed even today. Any object which has got mass will have its force of gravitation. Any object which has got mass will have its force of gravitation. Now, when we talk about planet Earth which rotates from west to east consistently. Now here, first of all, before this, one of the basic aspect, when we talk about a circular motion, when we talk about a circular motion, now, what is the distance traveled in the circle? Distance traveled by a circle can be considered to be the perimeter of the circle. If let's suppose this is the radius, we do know that perimeter of the circle is 2 pi r, isn't it? That is the radius, or that is basically the perimeter. So if let's suppose an object is moving across this circle, we can say that the distance traveled is 2 pi r. With that basic concept, let us understand one another simple aspect. That is, as the planet rotates on its axis consistently, let's suppose you have an individual who is standing here. Let's suppose you have an individual who is standing here and an individual who is standing here. Okay. Now, let's name each one of them. Let's name this as A. Let's name this as B. Let's name this as C. Now, A, what is the distance that A will travel? If I denote this circle with a radius r, if I denote this with radius r, I can say that the distance traveled by A is how much? If I name this geoid here, distance traveled by A in one rotation is how much? 2 pi r. Simple. If I talk about this position B, now what is the distance traveled by B in one rotation? So distance traveled by B in one rotation will be across this circle with a radius, again, let's suppose r1. So distance traveled by B is equal to 2 pi r1. Okay, how many of us are not aware about the about the perimeter of a circle? I hope by now, at this point of time in your life, all of us would be aware about the perimeter of the circle. No? Which class are we in? Have we all, I'm assuming all of us have basically covered at least class 6th or 7th. So you would have covered the perimeter of a square, you would have covered the perimeter of a circle. This portion you would have covered, or even this is not covered. How did you manage to clear the board exams? This is okay. Perimeter is double the radius. Okay. So a kind of it might be a rude awakening, but in order to clear this prelims examination, in case you want to appear for the mains examination, you will have to clear CSAT, the civil services, the aptitude test, where you have questions of quantitative analysis, etc., which is asked, where basically r- circumference, perimeter. These are the very base area. These are some things that, if I'm not mistaken, this is something that you would have covered maybe in your class fourth, fifth, or sixth. But nonetheless, in case you are not aware, distance traveled across a circle is equal to perimeter. Covered in a circle equal to perimeter. GIB and as Hussein, in which class are we? And perimeter of a circle is equal to 2 into pi into radius. Degree, graduation. Did you appear for the board exams, my dear friends? Nonetheless, and I would be very interested to know. Okay, right, open. Okay, fair enough. Nonetheless, this is the, yes, during, okay. So 2 pi into radius is the circumference or the circle or the perimeter of the circle. So that is the distance traveled. When you move in a circular path, that is the distance traveled. So 2 pi r is the distance traveled. Okay. So when we talk about this, that a person at A in one rotation, what is the distance traveled? That will be 2 pi r here. Now, a person at B, what will be the distance traveled by a person at B? That can always be thought to be 2 pi r1 here. If this is r1, we can think about the distance traveled to be 2 pi r1. Now, we do know just by simple appearance sake that r is greater than r1. We can have this understanding that r is greater than r1. Okay. Now, here, what about the person at C? Now, as the planet rotates continuously, the person who is basically stationed at the poles, right? So what is the distance traveled? Person who is standing at the equator in one rotation will cover the entire distance around equator. Person slightly above at B will cover that distance. What about the person at the poles? As the planet rotates, we can say that the person is almost going to be in the same place as the planet rotates underneath them, isn't it? So basically, can we say that the distance traveled by C will be how much? Can we say it will be close to zero? Are we comfortable with that? Hussein and GIB. Yes, can we say that? Okay. Now, one rotation takes 24 hours or 1 day. One rotation happens in 1 day. That is why you have sunrise in the morning, sunset, then again next morning after 24 hours you have sunrise. So 1 day basically means one rotation. So what is speed? When we talk about speed, what is speed? Speed is equal to distance by time. Are we aware of this formula? This is the formula I think that you study in class 4th. So even your excuse of corona won't work here, right? So speed is equal to distance by time. So speed of rotation experienced at A is equal to distance traveled by A by 1 day, let's assume. Speed at B, can we say that is equal to distance traveled by B by 1 day? Isn't it? Speed by C, that is speed of rotation of C, is equal to distance traveled by C in 1 day. time is 1 day here. So we know, based upon this, that distance covered by A in one rotation is going to be higher as compared to distance covered by B in one rotation, which is going to be higher as compared to distance covered by C. Right? So from here, can we come upon the derivation that speed of rotation at A is going to be much higher as compared to speed of rotation at B, which is going to be much higher as compared to speed of rotation at C, which is going to be 0. Speed of rotation at C is going to be 0. We can say that, isn't it? So basically, that gives us an idea. Are we comfortable with this? That is why when the planet rotates, the region at equator will cover a very large distance. Then comes the region at B. Then the region of poles. So speed of rotation is going to be maximum for the planet around the region of equator. At the region of equator, the speed of rotation is roughly 1600 kilometers per hour. It slowly and steadily decreases. And by the time that we reach the region of the poles, the speed of rotation actually ends up becoming 0. So that is where, if I bring that to the question, the speed of rotation at any point on the equator is at the rate of approximately 1000 miles per hour, which comes out to be around 1600 kilometer per hour, decreasing to 0 at the region of the pole. Speed of rotation is going to be highest at the region of equator. Distance covered is less, so speed of rotation is going to be a little less here, and the speed of rotation is going to be minimum at the region of the poles. Okay, we are comfortable with that, right? Hussein and GIB, are we comfortable? Good. So Earth spins on its axis from west to east. That is, basically, consistently it rotates on a direction west to east. It takes the Earth close to around 23 hours, 56 minutes, and 4 seconds to complete one rotation. That is the time taken to complete one rotation. That is what we call as 1 day, isn't it? So, but as the planet rotates, its axis is tilted. Its axis is not straight. Its axis is not vertical. Its axis is basically tilted. So here, if you think about the planet like this, here, now the axis is basically tilted. So here, what you have is that this axis is tilted from vertical at an angle of 23.5 degrees. This angle is 23.5 degrees. This has not always been consistent through the geological history of the planet. Throughout the geological history of the planet, this has changed multiple times. You will find few of the planets whose tilt is much more than that. You have few of the planets where the tilt is more than around 90 degrees, closer to 180 degrees in certain cases. If you talk about the planet Neptune, there the actual tilt is much more. There the actual tilt is almost to the opposite side. So this actual tilt, how is it decided? So it is decided right at the time of its formation, how the various different colliding forces led to the formation of the planet. So think about it. Let's suppose this is an object which is moving, it is rotating. It is hit by another object. Now, due to the force of the impact, it will have a kind of a tilt, that tilt, and then it will start rotating across that tilt itself because it is rotating in a vacuum in space. Then let's suppose, meanwhile, there is another force, another impact. Again, that tilt will be there. So like that, since the time of its formation, it has had multiple changes in the actual tilt. As of now, for a past considerable time, for the past few millions of years, and in fact, for the past few billions of years, the planet has had an axis of rotation closer to around 23.5 degrees. But this also keeps on changing ever so slightly every few 100,000 years. This also changes to around 24 degree or 21 degree. But we consider it to be 23.5 degrees. It is vertical tilt of 23.5 degrees, and basically the horizontal tilt of 66.5 degrees. Together, if you notice, they make up 90 degrees. So that is the actual tilt. But what is the implication of it? The implication of it is that the circle of illumination will be present here. Okay. So you will have a situation where at one point of time, either the northern part of the earth is tilted towards the sun and the southern part tilted away from the sun. And sometimes, let's suppose the planet comes into another position, northern portion gets tilted away from the sun, and so on. That is what gives rise to seasons, as we will take a look into it very shortly. So that is the case of the planet Earth as a rotating object. Now, this planet Earth, as you can see here in this particular image, planet Earth moves in a kind of an orbit, elliptical orbit around the sun. Ellipse is different from a circle. Circle means that from the center, all points are equidistant. That is the case of the circle. When we talk about an ellipse, it is not the case. Ellipse basically is somewhat like this. So that is where, if let's suppose you have the sun to be present here, the planet Earth continues to move around in an elliptical orbit. So there will come a point where the planet Earth will be farthest away from the sun. There will come a point where the planet Earth will be closest from the sun. But it keeps on moving in a kind of an elliptical orbit. And here in this image, if you observe carefully, observe the tilt. The tilt is maintained. The tilt is maintained here. So because of the tilt, you will have a situation that sometimes the northern portion of the planet appears to be what is referred to as the northern hemisphere. It appears to be tilted away from the sun. Southern hemisphere appears to be tilted towards the sun. Now, as the planet comes into this position, northern hemisphere appears to be tilted towards the sun. Owing to that actual tilt, southern hemisphere appears to be tilted away from the sun. Okay. So while Earth is spinning on its axis, it is revolving around the sun in an anti-clockwise direction. It takes the Earth one full year to complete one full revolution around the sun. Now, the mean distance of the Earth from the sun is around 93 million miles, or close to around 150 million kilometers is the distance. Average distances, average distance is around 150 million kilometers. Okay. So, because it is moving along an ellipse, you will have a position when the Earth is very far away from the sun. You will have a position when the Earth is closer to the sun, right? And that basically brings into equation the position what is known as aphelion and perihelion. Aphelion. So, helion here refers to the reference of sun. Helion is derived from Helios. Helios is a reference to sun. So when we say the position of aphelion, aphelion basically means the distance from the sun is the maximum. At this particular point, the distance of Earth from the sun is around 152 million kilometers. When we say that this is the farthest point away from the sun in the ellipse, and then a position will come where the Earth is around the shortest distance, that is around 147 million kilometers. So that position in its orbit when planet Earth is farthest away from the sun, that is what is known as aphelion. When we say that the distance is closest from the sun, that is perihelion. Similarly, when the moon also moves around the Earth, It is not circular. You will have a position where the moon is farthest from the earth, and you will have a position when the moon is closest from the earth. When the moon gets farthest away from the earth, similar naming. Ap means farther here. And when we talk about the moon and the earth, we use the term G because geoid, because earth, right? So apogee represents the position when the moon is farthest from the earth. Perigee, rather than perihelion, here between moon and earth, you use the term perigee. So the term apogee refers to that position of the moon when it is farthest from the earth. The term perigee represents that position of the moon when it is closest to the earth. So that is why if you have ever witnessed the satellite launches that we carry out, that ISRO carries out, basically if you would have noticed the graph that they show on the screen, they show you apogee and perigee for each satellite, which tells you that in their orbit, in their motion, moon gets farthest away and then moon comes very close to each other, right? So that is basically the case of aphelion and perihelion, apogee and perigee. When we talk about aphelion, this occurs generally on 4th of July. That is when it is farthest away, right? And is slightly closest around 4th of Jan. Okay, so 4th of Jan is when it will come closest. Now here, please don't get that kind of a confusion. But then in July, you are saying it is farthest, but we experience summer. In January, you are saying it is closest, but we experience winter. Why is it so? That is largely determined by the axial tilt, right? And that gives the rise to various different seasons, the variation in the length of day and night, as we will study and take a look into that. So Earth is at a maximum distance from the sun at aphelion and as its minimum distance at perihelion. Okay, the point on the moon's orbit where it is farthest from the Earth is called apogee, and when it is closest to the Earth, it is known as perigee. Okay, now then we come to the seasons on the planet. Why do we experience the various different seasons on the planet? So you would also have experienced. We are in the month of December, the midst of December almost. Now, the length of day, what you are experiencing right now, would be different from the length of day that you experience in May. In the month of May, you would have experienced that sun rises much earlier and sunset happens much later. In the month of December, you would have experienced that the sun rises significantly later, sunset happens much earlier. So the length of the day during these months is shorter, length of night is longer. In summer, you experience length of day is longer, length of night is shorter. Why does that happen? Again, because of the axial tilt. How? Let's consider this. Let's suppose we consider this. Now, each of these, they represent the circle of illumination, as you can see. The portion on the other side basically represents the daytime, and the portion on the darker side represents the area experiencing nighttime. Now here, let's assume this is the equator. Equator basically divides the planet into two halves or hemispheres. Hemi means half, sphere, half of a sphere. So this is what is known as the northern hemisphere. This is what is known as the southern hemisphere. Okay. Now, if you consider this position, you will find if you talk about the rotation of planet Earth from west to east, consider this and listen to this very carefully for the next 10 minutes. Listen to this very, very carefully for the next 10 to 15 minutes. Whatever doubts that you will have, etc., that will always be taken care of. So here, consider that northern hemisphere. In the case of northern hemisphere, this is the portion to the other side of the circle of illumination. This is the portion which is going to experience night, and the brighted portion will experience the daytime. Now, in this position, can we say in the northern hemisphere that northern hemisphere will spend more time in the lighted area, less time in the darker portion? We can say that because of the axial tilt, because of the position. Can we say that the northern hemisphere will experience or will basically observe a greater amount of time spent in the lighted area and less amount of time in the darker area? Are we comfortable with this basic fact? Yes? Okay, good. So if we are comfortable with that, more time spent in lighted area means length of day will be longer. Less time spent in the darker area means length of night will be shorter, isn't it? We can say that. So in this position, northern hemisphere, can we say northern hemisphere in this position will have longer days and shorter nights? What about southern hemisphere? When we talk about southern hemisphere, this is the circle of illumination. Can we say that southern hemisphere spends less time in the lighted portion and more time in the darker portion? We can say that. So in the case of southern hemisphere, we can say shorter days and longer nights. We can say that. Longer days means what? For a longer period of time, sun is shining. Means the ground will get heated up for a longer period of time. That means temperature will be higher. That means summer season. Longer nights mean and shorter days means what? It will be without sunshine for a long, so nights will be longer. We right now you are experiencing longer nights. So sunlight is for a shorter duration, nights are for a longer duration. Means winter. So in this position, northern hemisphere will experience summer, southern hemisphere will experience winter. Is that digestible? Are we able to digest this? Right? Perfect. Now, with the same axial tilt, planet continues to rotate. Now the planet will come into this position, then it will come into this position also. So in this position, as it comes here, this is your northern hemisphere, this is your southern hemisphere, right? Now, this is the circle of illumination which distinguishes day and night. Now, in this position, can we say about the northern hemisphere, it will spend shorter amount of time in light and more amount of time in during darkness? So northern hemisphere, can we say shorter days and longer nights? Something that we are experiencing right now. We can say that northern hemisphere will experience shorter days and longer nights. What about the southern hemisphere this time? Southern hemisphere will spend more time in light, less time in darkness. So we can say that southern hemisphere will experience longer days and shorter nights. We can say that. So shorter days and longer nights, winter in India, Canada, US, the entirety of Europe, Asia, winter season is going on. Now, southern hemisphere, longer days and shorter nights. You will experience what? Summer. Australia, New Zealand, Argentina, South Africa, they are experiencing summer season as of now. So different parts of the planet experience different seasons. But what about this position and this position? Try to understand this carefully. Axial tilt is still there. The axial tilt means tilt of the axis. Tilt of axis is still the same. But if you can imagine this as the axis of planet Earth, let's suppose you imagine this as a tilt of axis of planet Earth. If this is the sun, now this is the month, this is the situation of June. This is the situation of June when here you have the sun. The axis is such that the northern hemisphere is tilted towards the sun. The planet moves, comes here in the month of December. So northern hemisphere is tilted away from the sun. But what about this position in the month of September? In this position, or 6 months down the line in the month of March, in this position, in either of these cases, the axial tilt is still there. But what is the direction of the tilt? Can we say that northern hemisphere is tilted towards the sun? No. Can we say that the southern hemisphere is tilted towards the sun? No. Can we say that regardless of the axial tilt, both the sunlight will cover both the hemispheres equally? Sunlight will cover both the hemispheres equally in this case. Neither of the hemispheres are tilted towards or away from the sun. Both the hemispheres will be covered by sunlight equally. Can we say that? Right? That is where you will have the equal amount of sunlight spreading across both the hemispheres. So as the planet rotates, almost half of the planet will be lighted by the sun and equal half will be nighttime. So equal length of day and night. So this is basically the case of the various seasons. Let us elaborate upon that a brief. So this is the position which you experience in the case of winter months of the northern hemisphere. So this is your equator. Now here, this is your imaginary circle of illumination. This is your imaginary circle of illumination. Illumination. Right? Now, this position is largely present all the way. If the planet is situated here, if the planet is situated here, here, or anywhere, you will have a situation where due to the axial tilt, the northern hemisphere is going to be tilted away, southern hemisphere is going to be tilted towards the sun, right? So in this case, during the months of October, November, December, January, February, northern hemisphere is tilted towards the sun. Southern hemisphere is tilted away from the sun. Away from sun. Okay. So in this case, northern hemisphere will have longer nights or shorter days and longer nights. Oh, okay. Here basically the opposite has to be written. Away from the sun. And the southern hemisphere is tilted towards the sun. Shorter days and longer nights. That means northern hemisphere will experience winter, We are experiencing winter season as of now because of this position, because the northern hemisphere spends very little amount of time in the lighted portion, more amount of time in the darker portion. That is why we have long nights within the day, within the 24 hours. Southern hemisphere will experience longer days and shorter nights. That is why southern hemisphere is experiencing summer as of now. The temperatures are higher. It is summer season in South Africa, in Australia. It is the summer season. Now the region of the poles. Region of the poles indicates something very interesting. For example, if you consider this as the North Pole, obviously it is the North Pole. It is not to be considered. It is the North Pole. This is the region around Arctic. That is the Arctic Circle. This is your North Pole. This is your South Pole and the region that is around it, Antarctic Circle. Antarctic Circle. And this is your South Pole. Now here, if you observe it, in one complete rotation, regardless of how many rotations they do happen, will the North Pole ever come into the lighted area beyond the circle of illumination? Regardless of in this position how many rotations you carry out, will the North Pole come into the lighted area? What do you think? Will it come into the lighted area? No, it won't. Because as the planet is rotating in that tilted axis, and this is the portion of circle of illumination, it will always be in darkness. So that is why during these months, almost for the entirety of the period, the region of Arctic experiences permanent nighttime. Sun doesn't even rise up. That is where in the region close to the Arctic Circle, in the Arctic Circle, for example, right now, the region around Norway, the region around Greenland, northern portions of Canada, they would be experiencing permanent nighttime, no daytime at all, no sunlight at all. So the region of the poles, they experience almost 6 months. North Pole at this time experiences continuous nighttime for almost 5 to 6 months. Very cold conditions, very, very cold conditions. This is the reason why polar bears, they go for that long winter sleep where they basically don't move, they simply sleep in the same place for the entirety of the period because it is very cold and darkness. Then, what about the region of Antarctica at this stage? Antarctica and the Antarctic Circle, regardless of how many rotations they do happen, regardless of how many rotations happen, will it ever come on the darker side of circle of illumination? No. It will consistently be on the brighter side, isn't it? It will consistently be on the brighter side. That is why during these months, Antarctica experiences continuous sunlight. It is not, when you think about sunlight, the problem is because we live in an area which has got high amount of sunlight. When we think about sunlight, we think, okay, 2 p.m. in the afternoon, 1 p.m. in the afternoon, what amount of sunlight is there? No, that amount of sunlight is not there. But the kind of sunlight that you see at maybe 7 a.m. or 6 a.m. in the morning, or around 4 p.m., 5 p.m. in the evening, when the sun is very close to the horizon, very close to the kind of sunset or sunrise, it is in a slanting position. Antarctica permanently experiences this condition during this time. This is the time of the Antarctic summer. This is the time when the region around Antarctica, the coastal areas of Antarctica, they start melting. The penguins become active and all the polar expeditions to Antarctica that happens during these months, because it is Antarctic summer which is going on, right? So in this case, you will not have any nighttime, no nighttime in the region of Antarctica, in the region of South Pole. You would be aware of this earlier also, but many of us would not be aware why this happens. This happens because of the axial tilt of the planet. Okay, so in the region or during the months of October to February, Arctic Circle and beyond, no sunrise, continuous night. Antarctic Circle, no sunset. Sunset, continuous day. Right, that is the case during these months. Now, if you have noticed in your area itself, wherever you are living, you would have experienced that right from the month of October itself, the days they start getting shorter and shorter and shorter. In the month of October, maybe the sunset would be happening at 6 p.m. in your region. Now the sunset would be happening at 5:30, at around 5:45, 5:30, 5:20 itself. The days they get shorter and shorter. Around the time of 21st of December, 21st to 22nd of December, which is going to come within a week. So around that time, 21st December, that is when Northern Hemisphere experiences shortest day and longest night. Southern Hemisphere during the day, during the same time, will experience longest day and shortest night. This is the condition known as solstice. This is what is known as winter solstice in Northern Hemisphere or December solstice. Solstice or winter solstice in Northern Hemisphere. So if I ask you, on 21st of December, what is the duration of sunlight in the region of Arctic? Out of 24 hours, on 21st of December, what is the duration of daytime in Arctic? What will be your answer? Very good. Beautiful. 0 hours, no daytime at all, no sunrise at all. So it will be permanent night in the region of Arctic as of now. So on 21st of, around the time of 21st of December, no sunrise at all, permanent darkness, right? That is where even the human habitations, very few people live around the region of Arctic Circle, but those of them who live there, they are adapted to this lifestyle. They are adapted to this lifestyle of such continuous darkness. In fact, many of them, because it is a phenomena that many people across the world, they are not very well aware of. Many of them, they have started their own YouTube channels and are earning, minting millions of dollars of money worth of it just by showing the people that, look, today also it is only night, no sunrise. Tomorrow also it is only night, no sunrise. But this is a phenomena which will go on for 6 months, right? So that is the case of the solstice. Now, after this, we come to the position here where we saw this particular position, where the actual tilt is neither towards the sun nor away from the sun. It is in a different plane altogether. So in this position, this is the axis that is in the month of March, something that you experience also on September. This is your equator. The earth is tilted like this. The sun is on some. So if the earth is tilted like this, the sunlight is coming here. So the circle of illumination almost divides the planet in equal parts, halves, right? So in this case, when we talk about the rotation of the northern hemisphere, that is experienced in March, especially 21st of March and September, around 23rd of September. Why only March and September? Because if you take this entire movement to be 12 months, this will be 4 months, this will be 4 months, this will be 4 months, or 3 months, 3 months, 3 months, and 3 months, right? So after December, 3 months March, after that June, after that again September, like that. So in the case of March, you will observe, if you talk about northern and the southern hemisphere, can we say northern and southern hemispheres are neither tilted towards the sun nor are they tilted away from the sun. Can we say that? Neither it is tilted towards the sun nor away from the sun. Now we can say that this northern hemisphere will spend equal amount of time lighted and equal amount of time in dark. Same is the case with southern hemisphere. They will experience equal amount of time in light and equal amount of time in darkness. So in this case, length of day equal to length of night. You'll find 12 hours day and 12 hours night. This is a condition which is referred to as equinox. I will address all the questions once we get done with the portion of the seasons. Don't worry here. I will answer the questions. So even in the polar area, some amount of light starts coming in, right? Some amount of light starts coming in. Okay. Now, then after 3 months again, when we consider the conditions of June, here, this is your circle of illumination. The tilt is now clearly towards the sun of the northern hemisphere. If you consider this to be the equator, this is your portion of northern hemisphere. This is your portion of the southern hemisphere. This is the region of North Pole. This is your region of the Antarctic Circle or the region of South Pole. Here, this is your Antarctic Circle. This is your Arctic Circle. So, in these months, that is right after the position of March, all the way till the position of September, That is for the months of April, May, June, July, and August. This position will be largely maintained. We can say northern hemisphere is tilted towards the sun. The sun. Southern hemisphere is tilted away from the sun. So that means northern hemisphere will spend more time in the light and less time in the dark, right? More time in the light means summer months. Northern hemisphere experiences summer. Southern hemisphere will experience less time in day, more time in dark. Southern hemisphere will experience winter. So when India, China, Asia, entirety of northern hemisphere experiences summer, Australia and the regions thereby are frozen, or not frozen exactly, but they experience winter season, very cold winters. Okay, but what about the polar areas here? In this case, look at the region of Arctic Circle. Arctic Circle in this gives position, regardless of how many rotations it goes through. Arctic Circle basically will always be lighted. Will it come to the other side of the circle of illumination, to the darker side here? No. Arctic Circle will always be lighted. In the case of the Antarctic Circle, regardless of how many rotations it goes through in this place, in this position, it will be always in darkness. This is when the Arctic goes through the Arctic summer, or the melting of the Arctic happens. And you have 6 months of continued daytime. And the Antarctica region goes through the frozen period of very cold winter, where it is permanent darkness, permanent nighttime. So, this is where in the month of April to August, here, Arctic Circle, sun does not set, continued daytime, then Antarctic Circle, sun does not rise, continued night, right? And in the summer season, recall it from your own experiences. You would basically have experienced from the month of April, length of day, whatever is there. In the month of May, daytime gets longer. In your childhood days, when you would have gone out to play in the evening, you would have experienced that during your summer vacations, you would have had a longer playtime because the sunset would happen later, isn't it? On 21st and 22nd of June, 21st of June, Northern Hemisphere experiences longest day and shortest night. Whereas the Southern Hemisphere experiences shortest day and longest night. This is what is the June solstice or the summer solstice in the Northern Hemisphere. Solstice in the Northern Hemisphere or the June solstice. So if I ask you the question that on 21st of June, what is the duration of night time in Arctic? What will be the duration of night time in Arctic on 21st of June? What do you think? Zero. Perfect. So on 21st of June, Arctic will have continuous daytime. Right. Antarctic will have continuous night time. Now, all those of you who have the question that in which direction is the tilt there, sometimes you are showing the tilt in this direction, sometimes you are showing the tilt in this direction. Please let us know here itself whether it is east or west so that we can have peace of mind. Understand, east or west is basically our interpretation from planet Earth. We are standing in a place of planet Earth, so that is why we have the liberty to think east or west. Tilt is always in one direction itself, from whichever side you take a look at it. But here, think about it and look at this image carefully again. All those of you who were asking this question continuously, tell me the direction of the tilt, tell me about the direction of the tilt. Observe this image. The tilt is consistent in the same direction. Tilt is in the same direction. So you questions were asked by Twisha, Nikhat, Kanchan, Jyoti, all of you who were asking about consistently which direction is the tilt. Tilt is always in this same direction. If you are looking from this side, it might appear to you that the tilt is in eastward direction. If you are looking from this side, if let's suppose you are standing here and looking at it, the tilt might appear to be opposite, but the tilt is the same. But because the planet rotates in such a way, our planet moves around the sun, so you will have a position of the planet. If this is the tilt, actual tilt, again, observe this carefully. If my fist here represents the sun and this pen represents the actual tilt, so when the planet is here, it will appear that the tilt is towards the sun, the northern hemisphere is towards the sun. But if the planet rotates and comes here with the same tilt, it will appear that the northern hemisphere is away from the sun. If the planet comes here, neither of them is tilted towards or away from the sun. Both of them get equal rays. If it comes here, northern hemisphere appears to be tilted towards the sun. If it comes here, neither of them are tilted towards or away from the sun. Both of them get equal rays. If they come here, it is the southern hemisphere which is tilted towards northern. So the tilt is the same. It is due to the location here where you get that kind of an exposure. Is that understood now? Right? Jyoti, Twisha, Kanchan, Hussain, all of you. Good. Now, that is the case. So, because of the actual tilt of the planet, because the planet is tilted on its axis, that is why different areas they experience different duration of day and night. Had the planet not been tilted on its axis, let's suppose the axis would have been vertical, then in that case, all the regions would have experienced equal duration of day and night. This is the reason why during the time of the summer season, during the months of the summer, if you go to the region to the North Europe, northern portion of Europe, for example, northern portion of Canada, northern portion of Asia, for example, now here, what will be the pathway? If I can represent the pathway of rotation, I can say that this is the path of the rotation. This is the path of the rotation. This is where it goes. And it spends very short time here. That is why during the summer months in the region of Northern Europe, you know when the sunset happens? The sunset happens sometimes at 12 a.m. at night, sometimes even 1 a.m. at night. The sunset happens. Here we are used to a life from our childhood days. We are used to a life where at 5 p.m. or 6 p.m. it becomes dark. Imagine a life where it gets dark at 12 a.m. 11 p.m. also it is bright outside. 10 p.m. also it is bright outside. And then again at 5 a.m. in the morning, it becomes brighter, right? So in certain areas, you will have 10 hours or, close to around 20 hours of daylight and only 3 to 4 hours of nighttime during this condition. Okay, so it is because the actual tilt of the planet, different areas get different duration of day and night. Okay, yes, Abhay, that is the case, right? Now, after this, we come to the case of longitude and latitude. Okay, March equinox, September equinox, again explain. Okay, very elaborate a question. How the position of the sun experienced in case of no sunset. So in case when there is no sunset, let's suppose you are standing here, then the sun will be somewhere not vertically upwards, but very in a slanting position, very close to the horizon. So very slanting position, that will be the consistent position of the sun. Okay, and when we talk about the Garima, your question, equinox virtually means equal amount of day and equal length of day and equal length of night. Garima, March equinox and September equinox explain. So the case is that, see, here also in the month of March, the tilt is there. The tilt is there. But again, take a look at this. Carefully look at this. Patiently look at this. If the earth is in this position, one of the hemispheres is tilted towards the sun. I hope you understand this is the axis. One of them is towards the sun, one of them is away from the sun. What if with the same tilt the planet is here? None of the hemispheres are tilted away or towards the sun. Both of the hemispheres get the equal rays of sun, isn't it? So the same condition here, this is your position of the sun in this case. This is the position of the sun. This is the tilt. So basically, both the hemispheres will get equal amount of sunlight because neither of them is tilted towards or away. So equal amount of sunlight means the circle of illumination will almost be passing through half. Equal length of day, equal length of night. Okay, right? Now, after this, when we talk about the case of longitudes and latitudes. So basically, see, rotation and revolution. Rotation means when it is moving across and around its axis. That is rotation. Okay. When we say it is moving around the sun, that is revolution. Okay. Now, when we talk about latitudes and longitudes, so basically, these have always, latitudes have been in existence for a long period of time. These are imaginary circles and imaginary lines which are drawn. When we say a latitude, so it came into existence in order to help understand the location of a place, positioning of a place. In older days, in ancient days, when the mariners, when the sailors would travel large distances, they would require certain references and they would navigate with the help of the position of the stars and the position of the celestial objects. That is what would help them navigate and move from one place to another. And for that, they needed reference pointers on the surface also. And that is where they used the imaginary lines or the imaginary circles. That is what your latitudes are. So, latitudes are circles of parallels, parallel circles which don't meet with each other. These are your latitudes, they are parallel circles. Okay, the largest latitude is the one which passes through the central portion of the planet Earth. That is what is known as the equator. It is that equator which divides the planet into northern hemisphere and the position of southern hemisphere. Now, what about longitude? So, longitudes came into existence in order to keep a track of time. Different areas, they experience sunrise at a different point of time and sunset at different point of time. For example, Japan, Japan, which is referred to as the land of the rising sun, Japan would experience sunrise much earlier as compared to India. Right now in India, we are experiencing night time. Is it the case that across the world it is night time? No, obviously not. In the region around, let's suppose, UK or Britain, right now it will be somewhere around in the afternoon, right? 3 p.m. or 4 p.m. in the afternoon. Then, somewhere in the region of US, it would be early morning right now because the planet is consistently rotating from west to east. So, if India is here, as India moves to the darkness, some other region will come into brightness. So, every area experiences different time. So, when we say an event has occurred at 5 p.m., 5 p.m. where? 5 p.m. in India, 5 p.m. in China, 5 p.m. in Russia, where? So, for those purposes, basically, you needed a standard reference time. Many countries, they started following the reference time of UK and Britain because in the 1800s you had the British Empire at one of its peak. So basically, British Empire was very, very powerful. So the Postmaster General in London, which was a very powerful post also, he basically said that, look, we have these imaginary circles, we draw these imaginary circles across the planet also, north to south imaginary circles. And basically, let us consider the circle which passes through the Royal Observatory in Greenwich, close to London, as the standard circle, the standard longitude. The time observed here will be considered as the standard time. Rest of the clocks across the world will be adjusted as per the standard time. So that is what the longitudes are. And the one passing through the region of Greenwich in London, near London rather, that is what is known as the prime meridian. And all of them are basically a mere referencing to that. So the portion which lies to the east of it, that is also what is referred to as Eastern Hemisphere. The portion which lies to the west of it, that is what is known as Western Hemisphere. Okay. So basically, that is the concept of latitudes and longitudes. But how are they named? You oftentimes hear about the naming 10-degree east, 90-degree north, or 50-degree north, 60-degree south, 20-degree north, 30-degree north. How does this latitude and longitude get numbered? Basically, if you consider the latitudes, let's suppose you have to name this particular latitude here. You have to name this particular latitude. How do you name this? Whether it is 30-degree, 40-degree, 50-degree, how do you name this? So for that purpose, the reference is considered from equator. Equator is considered the reference point, or because it passes through the center, it is considered to be 0 degree here. Now from that region, you draw a line to the center of the planet, imaginary center obviously, and then you join it with the latitude in question. You join it with the latitude in question. You measure the angle. Let's suppose this is 40 degrees. So it is to the north of equator. So this will be, the latitude will be named 40-degree north. Right. Let's suppose you have to name this particular latitude. This particular latitude. How do you name that? You again join a line to the center here. If it carves out 50 degrees, let's suppose 50 degrees. So this will be 50 degree, but it is to the north of equator, 50-degree north. Let's suppose similarly, I have to measure this angle or this particular latitude, let's suppose. what will I do? Again, I will join this to the central point here. Let's suppose this makes 20 degree as an angle. So this will be named as 20 degree, but it is to the south of equator, 20 degree south. That is how basically they are measured. Okay, some of the important latitudes basically are, you will have the Tropic of Cancer, Tropic of Capricorn. So equator is 0 degree. Tropic of Cancer, which passes almost to center of India, that is 23.5 degree north. Tropic of Capricorn is 23.5 degrees south. Arctic Circle is around 66.5 degree north. Antarctic Circle is around 66.5 degree south. And the poles, they are considered 90 degree north and south. Why? Because again, with the same logic, if let's suppose I apply the same logic to the region of the poles, if I draw an imaginary line here, what will be the angle made? 90 degrees. So this is 90 degree north. Similar logic in the case of measurement of longitude also. So latitudes are your imaginary circles parallel to equator, right? They are named after the angle created by a line connecting the latitude to the center of the earth and the line connecting the equator and the center of the earth. So whatever is the angle created, that is basically considered to be that angle of latitude. When we talk about the longitude, in terms of longitude, basically here, how do you measure that longitude? So here, the prime meridian is considered to be 0 degree longitude here. This prime meridian, that is considered to be 0 degree here. Right. Now here, let's suppose I have to measure what is the angle of this longitude which passes through North America. Let's suppose. Now what do I do? From the central point of that longitude, I draw a line to the center, and here also I draw a line to the prime meridian. I measure the angle. If this angle comes out to be 120 degrees, suppose, it is to the west of prime meridian. So this will be your 120 degree west. Right. So that is how the naming and the numbering of longitudes and the latitudes, they happen. So if I gain a top view, let's suppose you are watching it from here. I gain a kind of a top view into this. So if I gain a top view, how will this appear to look like from above? It will give me an appearance somewhat like this. Where all the longitudes will actually be crisscrossing each other. All of them will crisscross each other, isn't it? All of them will crisscross each other. Right? So, if let's suppose, and here again, I want you to exercise your brain and apply simple logic, even though sometimes simple logic is what defies us. If let's suppose this is your prime meridian, which passes through Greenwich in near London. If this is considered to be 0 degree, what will be this angle? Apply logic. If this is your 0 degree, what will be this angle? Can we say it will be 180 degrees? Can we say it will be 180 degrees? Right? Simple logic, guys. This is 0 degree. This will be 90 degrees. This will be 90 degrees. This will be 120 degree, 140 degree, 160 degree. Can we say that this will be 180 degrees? Roshan, is that understood now? Okay. Now, if it is 180 degrees, that is the exact opposite of prime meridian. This is what is also known as anti-meridian. Anti-meridian. Okay, that is what is known as anti-meridian. So in between 0 degree and 180 degree, the planet again gets divided into two equal halves. This is what is known as the eastern hemisphere. This is what is known as the western hemisphere. Okay, right? So that is the case of longitude. So longitudes are geographical positioning markers that run from geographical North Pole to the geographical South Pole, intersecting at the region of equator. They meet at both the poles and specify the east to west position of a place. Prime meridian is set as 0 degree longitude, and it divides the earth into eastern and the western hemisphere. All other longitudes are measured and named after the angle they make with the center of the earth from the intersection of meridian and equator. That is how the naming and the numbering happens. International dateline basically is again closer to the region of anti-meridian. You have a line which distinguishes one day from the next, which differentiates, let's suppose, 13th of December from 14th of December. We'll cover it tomorrow. So basically, today we will limit it here. But before that, I want you to attempt this question, which had been asked in the prelims examination. On 21st of June, the sun does not set below the horizon at Arctic Circle, does not set below the horizon at Antarctic Circle, shines vertically overhead at noon on the equator, shines vertically overhead at the Tropic of Capricorn. So, what happens on 21st of June? Weber, when we see sunset, why we see the image of setting sun in river and not on land? Are you able to see the image of anything on land, Weber? On river, you will be able to see the image of buildings also. But on land, are you able to see the image of anything at all? That basically explains your question there itself. So, majority of you have given the correct answer in this case. So, on 21st of June, the region of Arctic experiences continuous daytime. So, we can say that the sun does not set in the Arctic Circle, right? On 21st of June, in 21st of December, the sun will not set in the Arctic. But on 21st of June, it basically will be that it does not set in the region of Arctic Circle. Okay? I hope that is understood. What is the concept of horizon? Leaderboard, everybody would have got, most of them have got correct this in this case. So there's no point of that. This is your leaderboard. Horizon basically is the case when you say that you would have seen, or if I draw it out here, if you have these buildings, you observe the sun rising from here, the sun rising from here, right? After some time, the sun gets bigger, isn't it? So this imaginary point where the sky appears to be meeting the surface, the ground, that is what is known as the horizon. Okay, this is what in Hindi it is also known as Kshitij. So that is basically your horizon. Twisha, is the question not understood? Is the question understood now? How many of you have not understood this particular question? Okay. So basically, on 21st of June, can we say that the Arctic Circle sun does not set? Is that understood now? Roshan, GIB, Anjali, Yug Singh, Twisha, Shashi, Shweta, Lakshmi, all of you. Is that understood? Right? So if we say that the sun does not set, on 21st of June, the sun does not set in the region of Arctic, what does that mean? That consistently, if this is the land surface, consistently sun will be shining from here. It will not set below the horizon. It will always be there. So that is the answer. Right? It's solved now? Okay. Sushmit, C point basically, see, at the point of equinox, you have the sun which is shining equally in northern and the southern hemisphere. So we say that it is vertical over the region of equator. Don't worry. I am assuming that many of you are going to study geography and many of you are studying geography for the first time. Have patience. Don't lose your patience. Slowly and steadily, we will cover this. Don't worry. Is it true that in polar there are 6 months day and 6 months night? Yes, almost. So, see, it is not exactly 6 month day, 6 months night, but the sun starts coming up during the time of the equinox, and the sun starts setting at the time of equinox also. So, you can basically reduce 1 month out of that. So, more or less. And yes, Mega, you can. And Vaibhav, if the sun is rotating and Earth is also rotating, then always the same part of Earth should. Why? Why that should be the case? Movement of sun is very independent from the movement of Earth. In the case of Moon, it is the case that the distance is so close and so near. That is why the same face of the Moon is held by the Earth. But in the case of Sun, it is far away. Okay. According to Kepler's law, when Sun is Earth is at perihelion, its angular speed is high. Because of this, it experiences less duration of. Can we also say this? No. We'll see. Temperature, Ashish, is always dependent on many of the factors. When we come to climatology, we'll talk about that temperature. Solar insolation or the solar energy is just one of the factors which influences the temperature. If the northern hemisphere is tilted away, and regardless of what is the positioning of the sun, solar energy can differ, but the wind pattern, etc., duration of length and night, all will be different. Okay. And is there any conflict between expanding force and pull of sun on Earth? Can we say that expanding force also plays a part in keeping the Earth? No, no. That expanding force, we are observing stars moving, galaxies moving away from Earth. When we talk about at the level of the universe, sun and Earth, they are very close to each other. So it is, see, it is not going to be the case that there is nothing keeping the Earth from falling onto the sun. Earth is consistently being attracted by the sun, but because it has got energy and force, that is why it moves in circular motion. Viveka, it is sufficient. You will study some more concepts about stars, etc., in the portion of science and tech. If a person is on pole, he never moves, always on the same position. Yes, if you consider the rotation, yes. During Big Bang, which collision occur in Earth? During Big Bang, you did not have planet Earth in existence. You did not have the solar system in existence. Solar system came into existence almost 8 billion years, 8 to 9 billion years after the Big Bang. Okay. Just attend the sessions, Twisha, and please revise the sessions, more than sufficient as of now, and read the newspapers. So that will be all for today. We meet again tomorrow where we continue, and then we will carry on with the formation of the planet Earth and the portions of geomorphology. Okay.